Problem number 2. From a 180-foot observation tower on the coast, a Coast Guard officer sights a boat in difficulty. The angle of depression to the boat is 7 degrees. How far is the boat from the shoreline? Again, draw a right triangle. I do that before I do anything else. Even try to understand what any of the words are, I draw a right triangle. Then I start reading it and see how I can label each of the sides. It tells me there is a 160-foot observation tower. Here is another assumption you should make. Buildings, towers, and trees are always, unless you are told otherwise, perpendicular to the ground. So here's the ground, because it's a side parallel to the bottom of the paper. Here is the side perpendicular to the ground, so that's going to be the tower. That is 160 feet tall. Now, the angle of depression, that's a term some people have trouble with. Angle of depression or angle of elevation are always the angle made with the horizontal side. So when it says angle of depression, it's actually referring to this angle right here, that angle 7 degrees. But that's not as useful to me as knowing that this angle is 7 degrees. And of course, according to properties of geometry, these angles are both the same angle. Now, what I want to find is the distance of the boat to the shoreline. So you have to understand that here's somebody standing at the top of the tower, looking out to sea, looking down 7 degrees. So there's the boat that they're looking at. And you can assume that the tower, bottom of the tower, is at the shoreline. So this side right here is the distance of the boat from the shoreline. So if this is the angle we're talking about, the 7-degree angle, the 160-foot side is the side opposite. And the distance from the foot of the tower to the boat is the side adjacent to the angle. So this time what we're looking at is, we know the angle, we know the length of the side opposite, we want to find the length of the side adjacent, so that takes us to the tangent formula. The tangent of an angle is equal to the length of the side opposite divided by the length of the side adjacent. So let's write that up. The tangent of 7 degrees is equal to the length of the side opposite, which is 160 feet, divided by the length of the side adjacent, which is what we don't know. Now, be careful. A lot of people forget algebra. Still have to do algebra correctly here. In order to solve for the adjacent side, first I have to multiply both sides by the variable ADJ, the adjacent side. So next step, the left side of my formula says adjacent times tangent is equal to 160. Then I have to divide both sides of the triangle, divide both sides of the equation by the tangent of 7. So that the length of the side adjacent is equal to 160 divided by the tangent of 7. And the answer you should be getting is 1,303.1 feet. One more problem, and this is problem number 7 on this worksheet. A ramp 12 feet in length rises to a loading platform that is 2.5 feet off the ground. What is the angle of elevation of the ramp? Guess what I do first? I draw a triangle. Draw a right triangle. Again, here's the ground. That's the ground. Okay, so if that's the ground, and I've got a cart that I want to get up onto a platform, that's the ramp. The cart can go up the ramp, and once it gets to the top, of course, it's up to where the loading platform is. So the ramp is 12 feet in length. That means the hypotenuse is 12 feet. The loading platform is 2.5 feet off the ground. So this side right here that goes from the ground up to the loading platform is 2.5 or 2.5 feet. We are being asked for the angle of elevation of the ramp. Remember, angle of elevation is the angle that's being made with the horizontal side. So that is the measure that we're looking for. So we're looking for the angle. We're trying to find the angle. We know the length of the side opposite. We know the length of the hypotenuse. Opposite, hypotenuse. Again, we're talking about the sine function. The sine of an angle is equal to the length of the side opposite divided by the length of the hypotenuse. This time we know the two lengths of the sides. We know the length of the side opposite is 2.5. We know that the length of the hypotenuse is 12 feet. This time it's the angle that we don't know. So what do you think that we would have to do to get rid of the sine on this side of the equation?